We're good. That's a gorgeous picture.
Is that not beautiful? Isn't that something?
It's wonderful.
Hello, Lord Putnam. How are you? I'm just getting the stream rolling again after doing Alan B. Smith's show tonight. And this is a continuation of Comets and Supernovas. We're going to actually look at a few other things as well. But it'll be kind of fun.
Are we using our nighttime voices?
What are our nighttime voices?
I don't know. It seems like we're whispering.
Oh, well, you know, I'm sitting here under red light in the Observatory Nerve Center. And it's 11:30 Eastern time for me, 12:30 Eastern time, well, Atlantic time for you. Your time is out in the ocean, so that's pretty crazy, but that's okay. But no, we're actually looking at a few things tonight beyond where we were before. And I'm
into tomorrow.
Huh? What's that?
I'm into tomorrow.
You are. You are actually into tomorrow. You're absolutely right. You are into tomorrow. It is entirely tomorrow for you. Tomorrow it is.
Yeah, the first half hour has been awesome.
Yeah, that was fun. We got to see the comet, and we got to see the supernova. And let me see where the comet is right now. See if it makes sense to try and dig it out. It's a few hours later, so it's actually lower in the sky now than it was earlier. So it's going to be less of a pretty image. It's going to be far less. So we're not going to check that out. But anyway, we shall keep going. This is the Flame Nebula that's right next to Zeta Orionis. And I absolutely love the flame. I love this entire area. And if you look down near the bottom of the screen, right down here, you see this cloud of blue. That's actually Reflection Nebula that's being illuminated by this star in here. And then right here is the Horsehead Nebula, which we can't really see because I haven't exposed for the Horsehead right here. In fact, I'm actually messing with the settings right now. This is a little bit brighter, okay? And I think that let me change the red back to what it was, just so you can see what the red's supposed to look like. Okay, this is how the camera saw it directly. I'm gonna kind of cut down a little the bluish tint that we're seeing to kind of get us back to a more realistic view. This is a little bit too green at the moment, but no worries. We're just gonna be playing around tonight with a little bit of the settings. But we're going to come down here and check these things out here in a minute. So the first thing I'm going to do is I'm going to go back to our remote view. And that's going to be this view that you're going to see here in a second. Okay, this is the remote view. This is Zeta Orionis. That is the left-hand star in Orion's belt. And that star is a beautiful star. It's a hot star, and its name, of course, is Alnitak. All right, and then the middle star in the belt is called Alnilam, and the farthest star is Mintaka in the belt. And here's a joke someone sent me today, which I can't claim, but I think it's really, really funny. Orion's belt is a waste of space. W-A-I-S-T. Is a waste of space. I only give it 3 stars.
I saw that.
Isn't that clever? It was on my wall there. Somebody wrote it.
I saw that last night, I think.
Yeah, I thought it was clever. Very clever. So this is Zeta Orionis right here. And this is that star that had that fuzzy blue nebula around it. And the flame is right about here. Now, if we go into our 4K video mode, and I'm showing you all the settings over here because I want you to see them. And if I just increase now our ISO, that is our sensitivity, you'll start to see it come in. and you'll be able to see, I think you'll be able to see the flame. It's right there. It's a little bit elusive. You can kind of see it in between. This red, as I've mentioned before, that's an artifact from the camera. That's based on the interior of the camera, the interior heat of the camera. Now, I've had this camera, by the way, just so you know, plugged in since, oh gosh, we started, the first stream was around 7 o'clock or 7:30.
Probably about 7:30 your time, yeah.
Okay. I've had it plugged in the entire time. I've actually had the battery in it the entire time. It was 100% when I started, and now the battery's at 72. So it's actually, this could go all night long the way this is now. I just really like this setup. Very nice. All right, so we're going to stop the video here, and we're going to come back to, this is a 30-second exposure at ASA 20,000. It'll be pretty bright, but let's see if we can get something. But first, I would like to actually bring us a little bit, bring us up a little bit. So I'm going to kind of bring that lower area into view maybe a little better. I'm just going to kind of bring us back down, move the telescope a bit. There we go. So now we'll do a 30-second shot of this, and this should be pretty cool. But we're going to have a lot of stuff. You know, we're going to have a lot of things going on. Hey, Daryl. I see Daryl's here. Yep.
Yeah, I have a few coming in.
Hey, why did Daryl groan? What's the matter, Daryl?
Oh, your horrible joke.
Oh, the waste of space?
The waste of space, yeah.
Oh, come on. Hey, Rockstar. That's fine, I guess.
It was a groaner, come on.
It was. I thought it was funny. And there's Ashley. Hello, Ashley. How you doing? Hey there, Ronald. Good to see y'all again. Now I see what's going on here. And there is our view again. Let me actually get into the view here, the view mode, where it'll help us see it better. So looking at this right now, we can actually see, I'm actually going to the viewer, just do this part here. So we took a few shots of this before, and you can see the previous shots. They're actually pretty much the same, except for, of course, this is the different object. And then we have the latest shot is down here at the bottom, and I have a way to actually just show us only that without having to worry about the confusion of the extra little thumbnails on the side. And now I see that, oh, we can only just see the beginning of it. I gotta take us up a little bit more. So let's go back to the remote, live remote, and just go up a little bit. Okay, the flame won't be visible to us anymore for a moment, but we'll just come down. I want to try and check out to see if we can grab the horse head. And I will go 25,600 ISO for 30 seconds. Now, I can also go a minute, 2 minutes, 5 minutes, and take pictures like that. But you know what? I think 30 seconds is the limit for all of us. I don't want to actually make people wait a minute, 2 minutes for an image to come in, which may or may not be good. So I have to, say that we'll possibly look at that, at another point, when for longer time exposures, okay? And that's fine. I don't have any problem with that.
And we have a question coming in.
Nice. Let me hear it.
Daryl wants to know, is Alnitak lighting up the Flame Nebula?
Alnitak is involved with the flame. Alnitak's a very hot star, irradiating a whole lot of space. And so, yes, the Alnitak does have something to do with it. How much, I actually don't know in particular. I could actually find out. But this is our, and I'll find out actually in the course of this stream, Daryl, because I would like to, I kind of knew the answer to that at one point, and I actually wanted to pursue that myself, to figure out what's going on. I am going to just do a little enhancement here to the red. We're looking, this right here is where the horse head is located. And the horse head's actually right here, and you can just see it. So what I'm going to do is kind of bring it out by bringing in the contrast of the area around it. Okay, and that I'm going to do by first dropping some of the brightness a little bit, and then grabbing some of the red and bringing up the red a little bit. And I think that would be kind of interesting to do. And it's going to give us a false color a little bit, but we might be able to see the horse head better. All right, now let's go back to just looking at our darks, and let's get the darks manipulated a little bit more. Let's try this. Usually when we do this stuff, we actually are able to bring out some details a little bit better. And I'm still certain that we'll be able to dig some more out of this, and I'm gonna just try right now to do one more thing. I've been playing with something called the tone curve. I'm gonna reset that and actually reset the whole tone curve that I've been playing with, because I don't like what it's done. So I'm going to bring it back to what it was when I took the picture, where we can now see a little bit of the horse head there. And what is the horse head? Well, the horse head is what's called a dark nebula. And as a dark nebula, okay, the horse head is very much a dark area of dust that's in place there, and the reason we see it is it's being silhouetted by a brighter red emission nebula behind it. And so we're actually seeing that in this way. So I'm going to be playing with these settings to try and find a good one to bring this out. Let's see. You'll notice the noise reduction kicks in. Well, you can see it right there. You can see the outline of it right there. And there's again, this is that reflection nebula with a little dark nebula that's sort of kind of just coming over it right there. So we're getting a little better.
What
here.
one's that called again?
This is a dark nebula. That's a reflection nebula.
No, but what? Like, we have the Horsehead Nebula. What's the other one?
Oh, that location?
Yeah.
Okay, well, that's
You don't know offhand?
I do. It's called NGC 2023 2023.
Oh, but it doesn't have a name, like the something nebula?
Oh, you want to call it the something nebula? Yeah, that's a good idea. No, it's actually it's just called the Bright Nebula. It doesn't actually have a particular name.
Oh,
it's about 1,500 light years away.
you know how I like names.
I know how you actually love names, and I think that's pretty cool. But I think
Whatever trick I can use to help me remember it all. Yeah.
Oh, it's all fair. It's all fair. It's all fair indeed. Yeah. Yeah. So I think that we've kind of looked at this a little bit, and usually when I stack these things, this is when these really show up well. So, excuse me. I'll be stacking some of these after. If we take more pictures, I'll probably take about 30 plus pictures of this later after the stream, so that you guys aren't subjected to this over and over. But that's okay. You guys kind of like this stuff anyway, so I think it's kind of cool. Now,
and for anyone interested in seeing those pictures, if you're on Facebook, you can check out SkyTour LiveStream with Mark D'Antonio on Facebook. I'll throw the link in chat. And all these pictures that he does take, he actually puts up, and you can check them out. You can download them yourself and do whatever you'd like.
You can do
Play
your own
around
image
with them,
processing.
stack them.
Yep. So I'm just
make
happy
memes
to
and send them to me.
make memes and send. Yeah, right. Go ahead, send memes to Amanda. Okay.
SkyTourRadio@kgraradio.com.
There you go. That's our email. And I promise I won't look at it before Amanda. Actually, I can't promise that. I probably will look at it. So you can see there's, we can do some processing to actually make some changes here. This is minor. There's so many other things that we can do here with within the process to actually help us to see, the results in a way that are more meaningful. And I can actually, and we're going to do this now. We're going to go back to our live remote view. Okay, this is this will be a view from, the camera directly. So this is a direct camera view, and I'm showing you the entire screen. I'm showing you everything that I'm utilizing. These are all the parameters of the camera. Not all of them. I've got some of them that are hidden, not shown here. Okay, like we're not showing the histogram. Okay, but the histogram can be shown. But we have settings for where the imagery is saved, which is good because I needed this. I didn't know where the pictures were being saved. They weren't on the camera, so all the work I did the other night was missing. I was like, where'd it go? I found it. It was actually on the observatory computer. So when we're done tonight, I'll be downloading from the observatory computer back to here, where I can then process it tomorrow and then put it all up on Facebook for you all. I have a bunch of raw images that I put up on the SkyTour LiveStream Facebook site already, and so they were put up from the last session, and I think that'll be something that you'll enjoy messing with and manipulating these as we so often do. I'm going to try going up to an ISO, as you can see here, of 40,000 for 30 seconds. That's a lot. I don't know what I'm going to get, but I'm going to try it.
40,000 pixels per frame?
No, that's a 40,000 ISO. That's the sensitivity of the camera, And I just want to let everybody know, hey, Laura Hovey's here. Thank you for coming again. Nice to see you. I see Benny Loco's here. I see Ronald's here. That's Earth Radio. And I'm going to be on Earth Radio tomorrow, guys, doing an interview with Ronald. Ronald actually wants to have me on his radio station, so I'm going to go on. It'll be kind of fun, so join us there if you would.
That's at 4 p.m. Eastern.
Yes,
on
4 p.m.
EarthRadio.com, and I will grab that link for you as well.
I thank you for putting that in. Yeah, let's just want to do this just to see if we get a little bit more data. And now I'm going to go into the edit mode on this as well and see if this helps us any. So let us to go. Oh, Laura, you listened to the Alan B. Smith interview? I did Alan B. Smith's show.
I didn't see you in chat. I'm glad you were there. Thank you for your support.
And Cryptic Warrior says, kind of boring. Well, yeah, I'm sure. I don't always.
Let me drop this link and then I can ban you.
Well, you don't have to ban him for saying that.
Well,
I'd like to know what he thought.
If that's the first thing you pop in with.
Yeah, I know. It's easy for us to be insulted. But you know what? He has a reason. I'd like to hear what the reason is. And maybe it's a valid reason. If I was boring, I want to know why. And I don't have a problem with someone saying that. I just want to know what their reasoning is. And if he has a good reason, then I will be happy to admit it and say, yep, I think you're right. Thank you for letting me know. But you never know. But, Cryptic Warrior, go ahead and tell me what was kind of boring. And
about a nebula in the universe.
Huh?
About a nebula in the universe.
Did he say that? Wait, is that what he said?
No, but I mean, that's what we're doing, so how is that boring?
Oh, well...
The universe is kind of a drag.
Yeah, I mean, maybe he thinks it's boring right now. Which it could be,
Impress him.
Well, exactly. See, that's the thing. We don't have... we're not always perfect with what we do. I mean, and it is kind of boring to see the same thing over and over, and I totally get that. So, let's figure out something else. Let's play around with other things. Let's go elsewhere. I admit I'm the one having the most fun, I guess, because what I'm doing here Yeah, actually, I already did Cryptic Warrior. I did talk about 46P Wharton, and we actually watched it. In fact, here I'll show you something that's not so boring. How about that? Let me just go into my viewer here and see these photos. Well, you don't see these photos. Let me show you the photos. Okay. All right. Let's just do this. So okay. Now you can see the photos on the left. These photos on the left represent these photos that we took earlier tonight. And guess what that green thing is? That, my cryptic friend, that is Comet 46P Wharton that we actually took a photo of a couple hours ago. And we're going to, it's kind of low right now, so we can't actually see it, unfortunately, because it's about to set. But there is something that we talked about earlier that actually isn't boring. And you can see the comet here this is called the coma. And we were talking about this star right here. And yeah, you're right. You're absolutely right, Cryptic. It's going to be, it's actually in the constellation of Cetus. All right. And it's actually
Cetus the whale.
That's right. And it's sort of, it's not really near Orion per se. It's actually, it's west of Orion, so it's toward the setting position. But
isn't it going through Pleiades and?
Yeah, it's not there yet.
Hyades?
It's not there yet.
No, on the 16th is when it's going to be closest to Earth. Is it not passing through Pleiades and Hyades?
The path takes it near there, yeah, and we'll be able to see it there. We'll have some beautiful photos of it. But this is the comet in Cetus as it is now. Now it's fast moving, and one thing I wanted to mention, again, to Cryptic, because he made the comment, which I think is valid. Okay, it's going to be closest on the 16th, and as it gets closer to us, it's going to be seen to be moving faster. Okay, and as Daryl now points out, as we just talked about, it's going to be between the Hyades and the Pleiades, yes. And
That's what I said.
Yeah, you did, and we're going to get some shots of it, probably with the rich field, wide field refractor on the telescope of it as well. But you see, like this star, okay, and the comet. This is a configuration that changes every few minutes. You can come back and take a picture 10 minutes from this point, and it will look different. It'll be in a different place. And as these pictures were all taken, sorry, that's the supernova photo we took earlier of the supernova. Don't worry, I'll get back to it. Both of those items are now kind of a little bit too low for us to see. You can see here that there was a problem with the telescope, and so I went back out and corrected it. And when I did, we got this. As you can see, it's a lot better. So this was a far better look. So I had a little issue. And then earlier we took this picture of the supernova in the galaxy M77, Messier 77, which is in the constellation. Hold on, let me see. Trying to see if this is the right one. Yeah, no, this isn't. M77 is also in Cetus, by the way. And so as we looked at it, we can actually see in some of the other photos, as I worked out the focus issues with it at the time, I was trying to figure out if I could find, after I collimated it again, I think I went back to it. I'm trying to find it again. Because I know we did, and I wanted to go back and show that supernova again. We did catch it earlier tonight, and it was very well. It showed very well.
While you're looking for that, Laura wants to know: is this comet going to affect us in any way? Which is a good question.
No, it won't. It won't affect us. You see, and by the way, this is a view. This is just what it looks like when it's out of focus slightly. Very bad. But I fixed it. So once it was fixed, we ended up being okay. And we will be re-imaging all these things again as we're moving forward. And let's see. And now Cryptic's asking another question. Next question, kind of nerdy, but that's okay. So are we. I have this poster with the center of said poster, the polar star with ecliptic and another plane. If I hung it on the ceiling, how should I orient it? Well, that's a good question. I don't know what the poster looks like, Cryptic, but I'll be happy to help you.
Well, in the middle of the poster is the polar star, and he wants to hang it on the ceiling. So
the center of said poster is where the center is. Okay, I know. Okay, where the center of said poster is the polar star.
Mm-hmm.
Where should you orient it? Well, okay, good question. If you're showing stars around that area, do you see, for instance, Cassiopeia? Do you see Cephas? Do you see the Big Dipper? Do you see the Little Dipper? Orienting it, if you put it any way you want, at some point or another, it's going to be right because the entire over 24 hours, the entire universe rotates around it. The sky rotates around it. So that's kind of cool. So I mean, it's right no matter how you put it. It just is a matter of what time you want your universe to be over your head, and at what time of the year you want that to be interpreted as. So you follow what I mean? That's kind of cool. All right, back to the remote for a second. Let's go to the remote live view. And
what time of night is going to be the best to see the comet on the 16th? So you're saying it's already getting low now, and usually for the meteors, the closer to dawn, the better. But it sounds like this we might want to be out a little early for.
Yeah, I mean, it's going to be rising in the east at sunset, and by around 9:30 or so, a little earlier than about 9:30, it's going to be almost heading to the south. It might be around the south. And so 9:30 or so is going to be about the optimum time, 9:15 to 9:45. That'll be the optimum time to view it. And on the 16th, if it's clear, we'll have a SkyTour LiveStream comet viewing party, and we'll be talking about it and everything. It'll be kind of fun. And let's see now. I'm going to go to a different place. And let's see if I can get us there. I can, I'm sure. Where is my beautiful Orion? There it is.
Ashley wants to know on this picture, the bottom right, that bright star, what is that?
What is that?
Yeah.
That.
Don't say a field star.
No, well, they're all field stars, right?
I know.
But we're actually in the Zeta Orionis region, so we're actually kind of looking near the Horsehead Nebula in that region. So I don't want to sound flippant by saying it's a field star, but actually those are two stars that kind of point sort of at the Horsehead Nebula. These guys right here you're talking about, I assume.
Yeah.
Yeah.
Well, that's what I was looking at.
I mean, if you actually want to know the names of those stars, okay, then I can tell you that star here on the right side is called HD 37699. Okay, and that's the HD stands for Henry Draper, and
I remember him.
Yeah, we talked about Henry Draper.
And his friend Giles. No. Was it Giles?
No.
Or something like that.
No.
Jorgen?
Maybe.
Gillis.
Gleese.
Gleese,
right? Gleese. Gliese. Yeah. And this
I knew it had those letters. I just couldn't pronounce it in my head. I couldn't make sense of it in my head.
Right. This little star, by the way, is known as HD 294297. So that's 294297, and this star right here is the star that I just mentioned before, which is HD. Let's see, which one was that one? I call it. Hold on. Okay, 37699. That's what it was. Yeah, 37699 is this little one. You asked the question, I gave you the answer. Kind of the way it is. Now, let's just take a look at. Let's go down here and look at this beautiful nebula it's right below, kind of near the Orion Nebula, but it's not quite the Orion Nebula. All right. but it's this area right here, and this is something that I think is really interesting. I did a kind of an expose of this nebula the other night, and it came out beautiful when I photographed it. It really came out just nice. It was so pretty, and it's actually called the Running Man Nebula, and the Running Man kind of looks like a running man. That's why it's named so. And what I'll do is I'll bring the Running Man up a little more. All right, and now I will expose it, and I'll say instead of 40,000, that'll make it pretty bright. Let's do 20,000 for 20 seconds. Yeah, 20 seconds. I'll go back to that. Okay, so now we'll do that.
And Daryl liked these ones. He doesn't have Facebook, unfortunately. He was hoping to get the images you took of this the other night. So I was on Skype with him, and I just shared my screen and showed him the pictures.
Oh, and I actually sent them to him.
Oh, did you? Oh, nice.
Yeah,
good. Thank you.
He'll tell you.
I don't know why I'm saying thank you, but
yeah.
No, I was showing it, and I said, any that you want, I could have downloaded and sent to him, but
that's okay.
You already took care of it. Nice.
Yeah. Yeah. Well, see, here you go. This is the Running Man. Look at how beautiful that is. Isn't that elegant? Now, let's just actually get into the editor a little bit and kind of, give ourselves a little look at the ability to just change some of the settings to make this look a little bit more beautiful to us. So I can just increase some of the settings here, darken things up a bit, bring it out against the background a little more. Okay, maybe like this. Isn't that stunning? Look at that. That is so pretty. And it's primarily a blue reflection nebula, okay? And these stars, of course, are illuminating it. And if we were to actually just enhance the blueness of this, then we would get something that looks a little bit like this, right? So we don't want to just enhance the blueness of the overall photo. But for now, by doing this, we can actually show the further extent of the nebula out here that you can see. It goes all the way out here. You can actually see, and this is the beginnings of the Orion Nebula down here, which we'll see shortly. There's some really beautiful and stunning, it's really beautiful and stunning views that we can see here, and I'm really impressed with how this looks in the telescope. It almost looks like it's unreal. It almost looks unreal. We can actually sharpen it a little bit. Sharpen it up a bit, and you can see now we can get a little more definition here in this Running Man Nebula. It's beautiful. This you see here, this is actually a dark nebula that's sitting over the top of this bright nebula behind it. And this bright nebula is being illuminated, not glowing. It's actually just illuminated dust. And it's being illuminated by it's being illuminated by these bright stars here, which are very hot stars. And you're seeing their starlight reflected, therefore they're very blue. Very interesting. And sometimes reflection nebulas can also look the color of the star too, and the reflected light of the star. So sometimes reflection nebulas have this orangey look, yet they're not emission nebulas. They're reflection nebulas reflecting a starlight. Really incredible stuff. And they look like artwork almost,
It does.
Yeah, it looks like a piece of art, And now if we want to zoom into this, we can actually kind of zoom in, and I sharpened it a little so you can kind of see some of the artifacts of the sharpening. But we can actually reduce some of that a little bit and kind of soften it up a little bit and give it a little less of granular look, which is nice, and make it a little bit nicer. But that's the beautiful Running Man, and I really, really enjoy the Running Man a whole lot. And
I take it it's a winter object?
Yes, it's in Orion. It's actually just above the Orion Nebula. As a matter of fact, if we go back to our live view of our remote view. Okay, as I said, if we go back to that remote view right here, this is what the Running Man looks like. Now, to your eye, I'll give you an idea what it looks like to your eye. When you look at it with your eye, all right, it looks kind of like, we'll just kind of go up a little more. Yeah, it looks a little kind of like this. You see a little bit of the nebula, which we see right here, right, and that's about what it looks like to your eye. In a dark area, it possibly looks even better, you know, to the eye. It could even look more bright. It doesn't have this green stuff. This is just the artifact of the camera doing its thing here. Okay, but turning off the camera's 4K mode and bringing down our sensitivity back to something more reasonable, and we'll bring it down to like 25,600. And if you want to know what I'm doing, it's what I'm doing is this right here. Okay, I'm bringing down this value to 25,600, leaving it at 20 seconds there for now. And now what we'll do is we're just going to go south a little bit, and you'll see where we're going in just a second, because look what's coming in now. Okay, ooh. Because this is the heart of the Orion Nebula, and I think what's really cool is we're going to take just a really short picture of this, and actually take it, and you might see the screen change in sensitivity a little bit as we drop this down. I want you to see what's going on here. All right, so let's go down below 3 seconds. And you quickly see now the screen, it's looking like it's losing some resolution. It's not. Okay, but we're going to take a 1 second photo of this, and that'll be at 800, as you can see. Why? I'll show you. So we'll take it, okay, and the photo's done. And now we're going to come back with our view. And what is the view showing us? Okay, let's take a look. Let's go into the close-up of the view. And if we go into our viewer close-up, we see that now if we zoom in on this, okay, we can actually see what's going on in the middle. We have 1, 2, 3, 4 stars in the middle of the Orion Nebula. And I will be fixing, you see this little weird stuff here? That weird stuff is due to my mirrors. I've got to align the mirrors far better than this. And yes, Daryl, of course, we are talking about the trapezium. That's right. And I know, Dave Schmidt, you were typing something in there, and I don't know if it was a question to me or if it's something you need me to address. Let me know, Amanda, what he was talking about so I can get to it.
For what?
I think he was typing some questions in there, and I don't know if he was talking to me or somebody else, but if he's talking to me, I want to make sure that I get the questions answered for him. That's all.
Yeah, I don't think he was talking to you.
Okay. All right, that's fine.
I'll let you know if the questions come in.
No, I know you will.
And just, you guys already know, but just in case there's any newcomers, if you do have any questions, please feel free, type them in chat, and I'll definitely ask Mark as they come in.
Sure.
Or if there's an item you want to see, if it's in the sky, if we can do it, we'll definitely take you there.
Absolutely.
Just let us know. That's what we're here for. That's what I was just saying. Try to be your eyes. Now I'm not needed because you're nice and toasty warm inside, so the glare of the brightness of the chat isn't going to ruin your night vision.
Well,
so now you can actually watch the chat too, but you're still pretty distracted.
The chat is a bright white screen, and I'm under red light in here, so I don't have it very large, so I can't really check it out, as good as I'd like to. Now I'm going to do this. This is if you see right now, I'm doing 12,800, but you know what I'm going to do? I want to go back to what the typical cameras did from like the past. The cameras having a 5,000 sensitivity didn't really exist. 4,000 no, 3,200 barely, but many cameras would go to like 1,600. Okay, and that'll be this stop right here. Some cameras would go to 1,600, and say they could go for like say let's say 3 seconds or 4 seconds. Okay, let's say 3 seconds. Okay, the photo you're about to see is the kind of photo you could expect if you would actually be looking with a camera from just a few years ago. So here we go. And we take the picture. The picture's being taken. 3 seconds later, bada bing, bada boom, and
Gorgeous.
we have this photo. Okay, this is what 3 seconds on the Orion Nebula would get you. And people would say, "Wow, look at that!" And if we look at it more closely, we actually see in the middle of the nebula there's actually some fairly convoluted areas. There's actually a lot of structural cloudiness inside this nebula. Which is, again, a very complex place. This whole region, all the way through all of Orion, is part of what's called the Massive Orion Molecular Cloud Complex, the OMCC. It's very, very large, a molecular cloud. And why do we see it so well? Well, we see it well because we are on a spur of a spiral arm in our galaxy called the Orion Spur. And this is where Orion is, of course. And so we see that. It's really an amazing place in the galaxy for us to be in. I guess anywhere would be an amazing place, and I guess I'd never basically discount any other place in the galaxy as saying that it's not as amazing, because it certainly is. So now, while we're here, why don't we just do another photo, and let's go through history here. Take it up. So I had a camera that did 3200 ASA, and let's just stick it 3 seconds just to see what the difference is. How would a 3-second photo at 3200 sensitivity compare to the first one? And we can certainly look at it. Okay, so if we go to the view and we go to our viewer, and let's just get rid of the parts we don't need. Okay, so this is that particular photo. Okay, and then this is, you can see the difference. Look at the difference. So between 1600 and 3200, you see what we get? A little bit of extra stuff. You can see a little bit of the extra parts of the nebula that are coming through as we get going here. All right. So clearly more details coming out. Now, if we jump back into our remote and we just say, well, let's do it again. Let's say we take a 10-second picture at 3200. I mean, that represents a fairly long time, and for the other types of photos that you might take, 10 seconds might produce, at this magnification, 10 seconds is going to produce some kind of blurring, if you're only on a tripod, with a telephoto. So this isn't even a real test. You wouldn't see it like this, but let's do it. 10 seconds at 3200, and you'll see how the Orion Nebula changes. So let's take a look at that. And when the view comes up, you'll actually see with the viewer. Now you'll see it. Okay, you see that? You can actually see now this new change. You also see something else up here, which is kind of interesting. Do you see that line?
Mm-hmm.
That's a satellite, and it's a satellite that
cool.
A satellite that winged right across the Orion Nebula. Now, as a kid, when I took my first 10-second photo of the Orion Nebula and I saw this, I was astonished. I was absolutely astonished. And this actually is sort of a zoomed-in photo. Okay, this is actually more what the photo looked like. So you can see this satellite moving across the field. And you'll notice it changes in brightness. It's going from brighter here to dimmer to dimmer to dimmer. So it's actually fading out. It's kind of a really cool photo as it's dimming out. I like this photo. Actually, that's kind of cool. So we'll tag this. We're gonna keep this photo and show it up on the website.
Definitely.
Yeah, for sure. And now, jumping back to the remote for a second, if we look and we figure 10 seconds there, well, what would happen if we actually did have it on a telescope and we did take like a 20-second photo at 3200? Okay, let's do it. 20 seconds at 3200. What would we get?
It's so crazy how that little dot of light up close looks like this vast, glorious place you can visit.
Yeah, I mean, it's several light years across, and it's actually, 1,500 plus light years away. It's a beautiful, fascinating location. Okay.
It's gorgeous.
Now you see this photo. This shows us something interesting now. I mean, they all do, don't they? This image here, you can actually see this sharp edge here. Okay. This sharp edge is sort of you can't see it in 3 dimensions, okay, really, but this is actually a reflection nebula area, and it overlays this area in the back, which is an emission nebula, okay? And the emission nebula is an area where the bright, hot stars, the trapezium stars, are actually causing the hydrogen gas to glow. And the way they glow is through a process called ionization. And the electrons, the hydrogen atom has a proton and an electron. Well, the electrons get so excited that they jump right off the atom when it gets hit with all this ultraviolet energy from these bright blue stars in the middle. And the electrons jump off the hydrogen atom, and now the hydrogen atom is what we call ionized. It has a +1 charge because the proton is +1, the electron's -1. So together they make a 0 charge in their base state. But when the electron gets bounced off, well, now it's a +1 charge. And now the proton is attractive to any other electrons. But for the electrons to come in to the atom and literally begin circling the nucleus and in the cloud that they do, they actually have to lose some energy and drop energy. So they do that through collisions out there as in their ionized state. And when they finally do come in, they drop an energy state as they drop into the hydrogen atom. And when they drop an energy state, they also are giving off energy, and that energy comes off in the form of light. And the light for this particular transition, it's called in hydrogen, it's called hydrogen alpha transition, all right, is a red light. And so nebulae that are stellar nurseries like this one do have this red component. This one, this color's just a little bit off. The color balance needs to be worked on a little. And let's go take a look at what that might mean for us. So if we're going to play with the color a little bit, let's do that. Okay, now right now I'm not doing any kind of sharpening or anything, but if I did, the Orion Nebula might look just a little bit differently, okay? This would be the sharpened Orion Nebula right here. And let's leave that for now. But let's go take a look now at our color. First of all, we can play with the hue. That is the way this looks in different colors. All right, this is a little bit more correct. This is not, okay, actually correct because we need to see the blue nebula, which is over here. But many times people show the Orion Nebula like this. That's not really how it looks. It does look more like this. It's called an emission. That's the red. Reflection. That's the blue nebula. So it's one of these emission reflection nebulas. It's both. All right. We can also.
Are 2 types of nebula in one common?
Yeah, absolutely. Sure.
More common than just one? One specific or
no? I mean we typically will see both in a lot of locations. Okay, because sometimes where you have gas being caused to glow like this, you also have dust, and if the dust is reflective, then we're going to see a reflection off the dust from the stars inside. And that's what we're seeing in this particular case. Now, if we hypersaturate this, okay, then it kind of looks a little bit too blue, and we can actually mess with the coloration again, play with the colors to get them right, okay. And this is still not quite right. We'd have to mess with it a little bit more. But the idea is that we don't want to make it too bright because it's not correct. This is about right, just like this, and this is really pretty. And this is like a blister, in space. This is a blister on this giant dark nebula within the Orion area. Okay, and this is of course small now. But it being small, it actually, if we want to enlarge it, it's really this is kind of, I think, just gorgeous. I love the way this looks. Now, inside the Orion Nebula, we found that there's a lot of stars forming, and they're all in here. They're all around here, and in this area of the nebula, believe it or not, there are these dark globules, and they're called Bok globules. They're actually very dark areas, and they're areas where maybe whole solar systems are forming or stars are forming along with solar systems, and it's just an incredible location. Now, the Orion Nebula is actually quite extensive, and I think that one of the things that make the Orion Nebula so attractive is, of course, all the colors, like we talked about, emission reflection. But at over 1,400 light years away, it's actually quite an object to have so close to us. It's actually fairly close to us. Lagoon Nebula is more than 3 times that far away from us, and yet we see some really nice detail with that. It's of course a summertime object, but the ancient cultures here on the planet knew about the Orion Nebula, and they could see it. So, for instance, the Mayans, for instance, they have a story that kind of implies they knew about the Orion Nebula. The funny thing is the nebula could be seen with the naked eye, and anyone can see it, and all of you can see it. It's right below Orion's belt. It's that fuzzy spot below the belt, part of the sword of Orion, and we can see that. But what's funny is there's no known historical mention of it before the telescope was invented. And I think that's kind of crazy. It was very, very vivid and very obvious. So I don't understand it, Oh, David, leaving? Oh, okay. Hey, thanks for joining us, man. I really enjoyed it.
Have a nice day, David. Yeah, he was just stopping for lunch. He has exams right now.
Okay. Yeah.
He's a teacher over in Thailand that drops by when he can.
Yep.
We appreciate it.
Awesome.
We have a few questions coming in.
Yeah, I see Cryptic's question. I can answer that. Actually, you know what, Cryptic? I think you'll want to hear SkyTour Radio this coming weekend, the next Sunday, because we're gonna actually have a special guest with us who's in the chat with us, I believe, now, and although he hasn't confirmed it yet, I think he's gonna do it, right, Amanda?
I hope he's confirmed it. It seemed like it was a go.
Yeah, his comment was perhaps. I didn't get a definite. Before I mentioned him, I don't.
Please.
Yeah, okay. I'm sure he'll do it then.
Oh,
So the bottom line is, we're going to talk about telescopes to buy, and you'll hear us say it again. But if you want to buy a really nice telescope, you're right. You don't want to go to Walmart. You're absolutely right. You want to go to something like OPT, or you want to go to Orion. Okay. And OPT telescopes, Orion, they have a lot of these wonderful scopes. You can get Meade or Celestron as well. We have a dome out here with a 10-inch Meade plus a 5-inch Richfield refractor, and they're stacked on each other. And we will use a camera on either or to show people things like you see right here. Now, it is a system that does have some tweaks, and that's why our stars are a little misshapen right now. We're out of collimation. I got to fix that problem, and it's definitely not an inexpensive hobby for people to get into it as a hobby. For me, it's my business. So I do this obviously because I got a degree in astronomy, and this is what I do I actually research this way too. So anyway, to answer the question for James' question about how much. If he's asking how much this costs, well, the dome and the telescopes inside, I mean, we're looking at easily $10,000. So that's definitely not child's play, for sure. But you can get a telescope like our main instrument. You can find telescopes like that and get a telescope like that for about $4,000. And then you can get a rich field refractor for as little as $300. You can get an observatory dome for as little as $4,000. So you can go on the cheap for all of it if you want to, and the results are not cheap. The results are quite good, but but the bottom line is, the telescopes, to get a good telescope for showing a view like this, they don't have to be $10,000 worth of telescope. Okay, the Orion Nebula is a really easy target. See all this detail in here? This is beautiful detail. And you can see all this subtle material flowing around here, these clouds of gas and dust, all influenced by the motion in the galaxy of the stars that are going through. Their stars' gravity are pulling on the atoms in this gas as well, and moving it around, bowing it out, causing bubbles in the gas. All these things are happening because of starlight. So it's really an incredible, an amazing, prospect to go hunting for nebula in the universe, and I just think that it's really, really cool. Now,
you're taking questions out of order.
I am?
Yes.
Okay.
And I had a plan.
Okay.
I was getting to yours, Pete, but I thought it might lead somewhere else. So I'm going to actually ask Dee's first.
Okay.
Regarding when you're doing the color saturation and the,
Yes.
fine-tuning details, how do you know if the colors are correct?
That's a very good.
How do you know what blue it's supposed to look like and what reds and stuff?
That's a very good question. There's a lot of color.
That was from Dee. Yeah.
Thank you, Dee. There's a very good set of photos that people take, and when I say people, I mean like the Hubble Space Telescope and others. And we know the colors of certain atomic transitions. We know those colors exactly, and that's what we try to match our photos to, because there isn't a transition of hydrogen, for instance, that goes to like orange. It's red, and we know exactly where in the spectrum that red is. And it's around actually 600 and or so nanometers. It's down around there, and it's this particular transition is a certain red that we know, and we can reproduce that and find that color, get that color to reproduce fairly exactly in our imagery. And then you modify the blue the same way, because there's certain reflections that you get off of these dust grains, and those dust grains reflect certain frequencies better than others, and you can actually get that particular color very well as well. And so that's how you know, because the colors have been deduced prior by looking at the exact atomic transitions that make the glowing colors, like the hydrogen emissions, or the frequency favoritism followed by the dust grains to do the reflection nebula. And it's actually a very interesting part of the science, to look at that. So that's actually how we know, Dee. That's an excellent question.
Excellent. And on the tail of that, although I know, Pete, you asked the question before D, but just in case, depending on the answer, Pete wants to know what the most colorful system you have seen has been, Mark. And depending if it's something we can see now, maybe we could go there, if it's possible. I don't know what the answer is, though.
Well, I have to tell you, this nebula has a lot of color variation. You can see all the colors in here. We're seeing, the blues, the reds. We're seeing a lot of the blends, between the two colors that look like they're blending. Again, all illusions. But the fact is, what we're seeing here is a set of color schemes that really represents a tremendous, an excellent summary, I should say, of what the universe holds for us and what the different atomic transitions are. And I'm just really interested in all of it, to be honest. I think it's really cool. So this is an example. The Orion Nebula is an example of, I think, one of the finest things that the universe has to offer us, the finest object. Why? Well, because the Orion Nebula actually has a benefit. It's actually one of the closest nebulae to us, and we can see it in the most detail of almost any other nebula in the sky, and that really is incredible. Now I'm playing with the some of the settings. You can see that we're getting a little more detail out here in the nebula, in this outer skirt of the nebula, and I think that's beautiful. It's just stunning, and we can kind of enhance a little bit of that. Now you see a little more out here, which is nice. Beautiful stuff, man. It's just a gorgeous nebula. It's always been beautiful to me. It's always been a beautiful nebula.
It is. I love the colors.
Yeah.
I love the detail of it.
Yeah, it's got
It's
a lot
like I don't see any pillars. You keep saying they're the dark lines and stuff, but it, to me, far away, it looks like an angel holding like a blue crystal.
Yeah, it does. It looks like, anything your mind can make out of it,
But like it has more detail. Like it looks more three-dimensional than like it looks like or it could even be an alien, something holding this blue galaxy. Like
yeah,
it looks like a made-up image. It does, like it's not detailed enough to say blah blah blah, but like I can make out a little face and I can make out little hands.
Yeah, it looks sort of fake.
Yeah,
it almost
like someone
does.
added a bit of detail.
It almost does.
Like that's what that's what aliens are doing. They're holding our galaxy together and peering in.
Yeah, I get it. Yeah. I just think it's all very cool. See, now I did a more enhancement. You can actually see a lot more of the convolutions on here. You see these little areas here, there's brightness, little edges of brightness down here and here. These are all very intricate areas that the Hubble Space Telescope has taken photos of. And when you look at the photos, you say, wow, there's so much going on in the Orion Nebula. So much. It's absolutely astonishing. So if we go back to the remote now.
Dee has a follow-up.
Okay.
And I see other people have questions. I am getting to them. Don't worry.
Yeah, don't worry, she says. Don't worry, she says. We'll get to him,
first.
She says.
Come on, gentlemen. Oh, actually, I think one's from Laura. Sorry. But it's just this one is actually related to what we're looking at right now, so okay. I'm prioritizing. Dee wants to know, when Hubble takes pictures, does it capture the color immediately, or is it added in later?
Very good question.
A good question.
Yeah, see, the Hubble sensor doesn't just take color photos. It takes colors in different bands, that is, different frequencies, and then they're added together. So let's look at it this way. You can take a red photo, a green photo, and a blue photo of the same object. That is to say, look at all the red light from the object, the green light from the object, and the blue light from the object, basically. And when you add it together, you get all the other colors, plus you get the addition of seeing what each component contributes to the image. And you basically can use different types of filters as well. Like we can use an oxygen 3 filter along with a hydrogen alpha filter and a silicon filter. And those three filters will show you specific things going on in a nebula that show more detail than you can imagine. And that's the really cool thing that I will be doing eventually. And what we're going to be doing is doing that with what's called a filter wheel. We have a filter wheel. And the filter wheel goes on a telescope, and the telescope filter wheel will be able to go through these three filters for each photo and do that as many times as necessary. And then we stack all three images, all three filter images independently, and then stack the final images together. And that makes a different type of image, an image that's far more informative and tells us a lot more of what's going on in the image. So yes, they're taken as separate separate filters, separate frequencies, and then combined later. That's how it works. That's how satellites actually work when they're orbiting the Earth. They actually do RGB shots of the Earth. And for the show What on Earth, many times, I'm their image analyst type thing. And when we look at the RGB images from space, we'll often see stuff on the ground that's moving. We'll see things like, if we look at the, this is beautiful. If we look at things like an aircraft that's moving on the Earth along the ground, we'll actually see that it's leaving a trail of RGB camera frames, and you'll actually see an edge that has a red, green, and blue fringe on it. So I think that's pretty cool. And Daryl wants me to talk about the Hubble palette. Is it time to answer? Yeah. Can I talk about his question?
Well, it's bumping one of his other questions, and it's bumping poor Laura's question.
Oh, okay,
but go for it.
No,
it's still on the topic of color. So while we're here, I have them written down. They're not going anywhere.
I don't want to skip Laura's question. If she was first.
What she wanted to know. Let me phrase it properly.
Okay.
How do we get a star named for an individual? The best way without getting conned. I think, unfortunately, I know the answer to that.
Well, there is. You can name a star. Actually,
is it official though?
It absolutely is. It goes into our registry. Yeah, I mean some. Yeah, okay. Well, okay. Laura, you got to be careful. Some of them are a little unscrupulous, and some of them say that your star is going to be registered, but they don't actually do it. So you can get conned. But the bottom line is, I think that it was really important. I actually had someone buy me a star once. I mean, there's certainly enough of them out there to go around.
Well, we were talking about that earlier in chat and hoping she didn't get conned, so that's where the question came from.
Yeah, no, that's okay. And honestly, Laura, I think that there are. I think if you look in Google, it'll probably tell you who actually is what organization is best for doing that. Because I understand your concern. We talked about
this before, and you said even if you discover a star, it's still cataloged regardless. Probably in the new general catalog.
Well, new general catalogs for objects, but still, your point is taken to mean that, and I take it and I get it. It's taken to mean that if you actually were to find something odd in the universe, you may not get a chance to name it. And Laura, your mother bought you one some years ago. Well, you know what? That might have been valid because I know there was a name a star thing. It was all over the news. People said it, and it became a real thing.
Yeah, I heard that too, but
yeah.
Then I heard about a lot of cons. So
yeah, and you gotta be ready to deal with that and not deal with.
Yeah.
By the way, in the early years, we only taken black and white images, so we got Orion nebulas that would look like this. All right, and your eye can't see color in the nebula. That's the problem. There's not enough light to fire off those cones in your eye when you're looking at a nebula, as bright as it might look. At the most, they might fire off the green because your eye is most sensitive to green light, believe it or not. And so you would see a greenish tinge to a nebula, but you might not see, all of this tinge. You wouldn't see these colors.
If I was looking at a telescope, I wouldn't see the color?
That's correct. In the Orion Nebula, it only looks kind of whitish.
What?
I know, rip off.
Why are you seeing it?
This is the camera that's taking the picture. We're talking about the human eye and how it perceives color. We don't see. That's the thing. Unless your eye can have the cones fired, you're not going to see this beautiful red nebula. A camera sees things differently. It's a sensor. It's tuned to picking up these different frequencies. Your eye is most sensitive to green light. So nebulae.
Yeah, but I thought a telescope would be powerful enough so you could see the color with your not naked eye. I thought that was the whole point. Not naked eye, but through a telescope.
No, but when you look through a telescope, you'll see the Orion Nebula. It just looks like it looks like I just showed you. Yeah. It might have
I didn't know that.
It might actually. Let me see if I can simulate what you see. It won't look like this. It's gonna look more. You'll see these areas appearing kind of green, and that's kind of what you'd end up seeing. What you certainly wouldn't see is this. You would not see this full color at all.
Wow.
And that's sad.
I am disappointed, D. I had no idea. I thought that was the whole point of getting a telescope.
No, the point of getting a telescope is so you can show images like this The telescope is a giant open-mouthed light bucket pulling in all this light, but it's still a very
But no
small.
color.
No, it pulls in color clearly because we're seeing it. But
Well,
trouble
that's
is,
the camera though, but not the telescope.
no, that's the camera, not your eye. Okay, the telescope's bringing in the color. The camera sees the color the telescope's bringing in. Your eye can't perceive the color.
I know, and that's what I'm saying. Without the camera, if I was just looking through a telescope, I would see the nebula in black and white. I wouldn't even be able to make out what it was unless I had the colors.
No, you would. The thing is, when you look at these nebulae in a telescope, they're very faint and they're distended. Like this means they're extended outward, right? Distended, it means that. So when you look at that, you're gonna see the brightness for sure, but you're not gonna see this richness of color at all. And like I said, your eye is best tuned to green, so sometimes people see nebulae as green to their eye, which is kind of disappointing to me. Kind of disappointing. I actually while we're here, I want to try something. Hold on. And we're going to have to go down just a little bit, but it's right near the Orion Nebula. This might be something we can try.
And Laura's right. You do spoil us. I'm so disappointed. I mean, a year ago, I didn't even know this stuff existed. Honestly, I don't know if I even knew what a nebula was, let alone different categories of them, different classifications.
Oh, well, I think...
I mean, I'm still not really sure I could explain what a nebula was to someone else, but at least I'm familiar with the term now, and I've seen examples of them.
Yeah.
I mean, I'm getting there. It's a lot. This is all of it. I have no basis for any of this. It's I don't know. All brand new information to me, so I'm doing well.
Yeah, I think it sort of is new information. You're right.
And that's why, and I know you say I'm too critical of myself, but a lot of the people that come to these chats, they do this for fun, and they've been doing this since they were kids, and they've watched the movies, and they go to the websites, and they've been following all this kind of stuff for years.
Yeah.
And me, I'm like, oh, those are pretty twinkling stars, like.
Well, that's fine. Yeah, a lot of people do that though. A lot of people want to just see the pretty, Yeah. Now, just down below,
I like the colors.
Just down below the Orion Nebula, is an object that's it's holding position over the same place on the Earth as the stars rotate around beyond it, and that's this object right here. You see that faint line?
Mm-hmm.
Okay.
Satellite?
Actually, that's a geostationary satellite. It's hanging over the same spot on the Earth. But see, we're actually, as we rotate out from, as we're sitting here, okay, the stars, we're following the stars. So the telescope is actually tracking all these dots in the sky, these stars. Okay, but the satellite is sitting over me right now. Okay. And so what we get is the satellite makes a trail, but it's not moving. The stars are. We're just following the stars. Okay. Now, if we turned off the drive on the telescope, then this here would be a dot. Okay. It would be the dot of the satellite just sitting there, and we'd see star trails, lines. It's easier to see these geosynchronous satellites. These are satellites that are over the same spot on the Earth. They're 22,500 miles out from the planet Earth in altitude, and that puts them over the same spot. And that's what this is. It's a geosynchronous satellite. We went hunting for geosynchronous satellites one night in SkyTour LiveStream, and we had a lot of fun. And there's some locations actually where there's more than one satellite in the same location, and I want to see if we got any nearby to just poke around with. Oh, we do, and it's down near another part of Orion. So let's go back to the remote.
Did I hear a dog?
Yeah, Dingo's down here with me.
Hi, Dingo.
Dingo Amanda says hi. And now let's move. She didn't even respond. It's like she didn't even care.
Tell her I'm a cat person.
Oh. Cat
That
lady.
might perk
Got
an
a cat
ear.
lady over here. Where's the kitty dingo? Yeah, usually she's ready for war when I say that. Okay, let's take a quick one here and see what we got. There should be 3 satellites hiding in this field. And this will be 20 seconds at 10,000, as you can see right over here. 20 seconds for 10,000 ISO sensitivity. Let's see if we get the 3 satellites that I expect to see in here. I'd be really curious. And here it comes. There we go. Look at that. There they are. 1, 2, 3.
Wow.
See, there they are. See, so these satellites are hanging out. They're out there all the time, sitting over us and just hanging out. So these 3 are out there. These are the XM. These are XM family of satellites here. Okay, so XM radio comes from these satellites in part.
That's what I was just thinking.
And it's true. Isn't that cool? So that's
very cool.
That's a set of XM satellites out there. And it's amazing how much space junk is, and this isn't junk, of course, but how much stuff is sitting over our head that we don't even know about, you know. And that's kind of cool. I like that. Now let's see what else we've got out here. Okay. Well, I know.
Still have questions.
Okay, yeah, please go for it.
Daryl wanted you to keep talking about the spectrum, the color spectrum of, the Hubble palette.
Oh, the Hubble palette. Yeah, the Hubble palette is a really interesting palette. And what's a palette? Well, the palette is a set of colors. And we're looking at a normal palette, okay, of colors, the colors that the thing really appears. But the Hubble palette, actually, they have different colors for different wavelengths of material. And they show these different colors, and that's not true color. They're what they're called false color images. But the colors they choose help to distinguish some of the material from other types of material in like a nebula or something. It's really interesting. And I actually have, I wrote a little program within Photoshop to create a Hubble palette for any images that we take in the SkyTour LiveStream, and you get images that look like a Hubble photo of them. But it's only a simulation because the Hubble photos are actually made from the hydrogen alpha filter, the oxygen filter, and from the silicon filter. And those photos are generated, that false color is generated from those particular filters. So I don't have those filters now. So it's nothing that I can do. I have to fake it, and I don't fake it. So are there others, or should I kind of go on to some of the other questions? Tell me.
Laura wants to know, will the Webb telescope equipment enhance color further?
Well, the Webb telescope is going to be 24 feet in diameter, as opposed to the Hubble Space Telescope, which is 8. Okay, it's literally 3 times bigger, basically, or 21 feet in diameter, I believe. Actually, so it's going to be almost 3 times bigger than the Hubble, and the Webb telescope is going to have its own capabilities, its own abilities to see the color its own way.
Its own palette?
Well, I mean, they may put the colors into a specific palette. And I think that's kind of cool. And I gotta just correct myself here. When they say I wrote a program within Photoshop, it's actually a macro, and basically you use the commands within Photoshop to actually do specific things. And I started writing one, and next thing you know, I've got like 10 different routines that I've written within Photoshop like that. And people write these all the time. There's a lot of specific things that people create to do certain things in astronomy. But some of the tools I didn't like, and some of the tools I wanted to improve on. So I did do that extra, and it's all part of what I do. And this is kind of addressed at D, who kind of suggested, you wrote something in Photoshop. Yeah, it's sort of a macro. It's a collection of Photoshop commands, which is kind of cool.
Daryl said hydrogen should be red. Is he suggesting maybe the palette does not show that?
In what context?
I don't know. Says hydrogen should be red.
Yeah,
as opposed to
is he responding
something
to
not showing it red?
I think is he responding to somebody else who said something else though? Because he had an exclamation mark.
Responding to you. I could be wrong. Let him clarify.
Well, no, hydrogen is red. Hydrogen alpha is red. I mean,
yeah.
It's like.
Is it in the Hubble palette as well?
Yes.
Okay.
Hydrogen alpha is one of the key items. Yes.
Oh.
And hydrogen alpha may be shown in a different color just to distinguish it, and that's something that will often be done. You know, the Hubble palette was just chosen because it can show a variety of, I guess, a variety of things a little bit differently in that object, and the way it'll show it is in that but in that change of the palette.
It's a different color in the Hubble palette.
It might be a different color. The Hubble palette has different colors. I play with the Hubble palette a lot actually, and I will take the hydrogen alpha, which I think actually is green in the Hubble palette. It's supposed to be red, but the false color might be green, and I actually show it differently than that too. So I play around with it, and I don't have the right filters to make an actual Hubble palette image, so I don't really mess with it that much, frankly. I could and I should, but I don't. Just the way it is.
And Rabbit says he thought that oxygen reflected red light. Oxygen is blue, isn't it?
Yeah, oxygen. Well, of course, it depends what we're talking about. If we look at doubly ionized oxygen, all right, that's O3. I mean, O1 is the Roman numerals. Roman numeral 1 is the base state of oxygen. Okay, where there's nothing ionized. In other words, it has all its electrons. O2 is singly ionized oxygen, and that's O Roman numeral 2, so OII. All right, and then O3 is the doubly ionized oxygen. And when those electrons jump off and when they recombine, there's a characteristic transition where they drop some energy to go into these particular shells in the atom, the oxygen atom. And when they do that, they give off a characteristic greenish blue light. All right, so we'll see greenish blue in oxygen, and usually in these planetary nebulae, because oxygen is one of the, in these stars that are kind of like the sun, oxygen could be one of those elements that's made in the star and then released when the star actually goes back to red giant and then white dwarf. So, I mean, that's all part of it. I don't know if that helps anybody, but that's, I think that's kind of what people were asking me, but I could be wrong.
Okay. Let me I know we have some more questions. I just want to go back to the beginning and make sure I didn't miss any.
Oopty-doopty. We have
fun. God. Okay. Daryl wanted to know, because we bumped his question for more feedback on Dee's previous question.
Okay.
His other question was, if the Tarantula Nebula in the large Magellanic
Cloud,
Magellanic, oh my god.
Magellanic.
It's 2 a.m. for me, guys. Please bear with me.
It is? Wow.
Just about, 5-2.
I know.
Anyway, if the Tarantula Nebula in the cloud was the same distance as the Orion Nebula, would it fill half the sky? Oh, it would fill half the sky. Oh, never mind. I'm sorry. That's a comment, not a question.
Yeah. Yeah.
I thought he was asking, would it fill half the sky?
No, no. See,
Apparently it would.
well, the Tarantula Nebula. Remember, well, you may not know. See, where is it? It's in what's called the Large Magellanic Cloud. The Large Magellanic Cloud is a companion galaxy to our own, and it's sitting quite a distance away. All right, many tens of thousands of light years away. So, the Orion Nebula is only 1,400 light years away. So, if you brought that, if that galactic nebula in that galaxy, this companion galaxy was brought in here, it would take up a great deal of the sky. Absolutely. So, yes.
Okay, now we have a real question. It's not just a comment, it's an actual question.
Okay.
Okay, this one's from Pete. What do you know about the Booty's void? Why is it so empty?
Oh, that's a question I get asked every once in a while, and
yes, I'm familiar with the term, but
yeah, I mean, it's an area of space that doesn't seem to have a whole lot in it, and the whole point of this is that we're trying to figure out what's out in space, and here we have this void, this apparent lack of anything out in this particular location. The question is like, well, what is that? Where does it come from? It's kind of it contains very little. I mean, there's some galaxies, but very few galaxies. Okay, and when you look at it, okay, it's literally in terms of its size, it's got to be over 300 million light years in diameter. It's massive, and it's probably, in terms of the amount of space it takes up. I'm trying to remember the origins of the research, but it takes up this massive amount of space spherically in the sky, and it could just be what's called a supervoid, an area of the universe where it just happens to be devoid of some stuff. Now, for instance, we look at a galaxy and we look at spiral arms in a galaxy, and we see that there's very, very tight knots of material, then there's nothing for a while, then tight knots, and then it seems to be random. Well, the Booty's void is an area in the galaxy where there's actually, not area in the galaxy, actually, an area in the universe where we have a similar thing, where the material is also not distributed in a way that seems consistent with other areas of the galaxy. And this shows us that the universe, it's about universe. When we talk about the universe like this, the universe, when it expanded, from the very first time it expanded in an uneven manner. Okay, it didn't have a uniform, homogeneous formation. It had spurts, and it had knots, and it had a clumping, as we call it. And this clumping is part of the problem, that causes these variations on these vast universal scales. All right, and this is a massive area. And so, basically, the bottom line is that because of the size of the Booty's void, okay, I've heard it said that if our galaxy was actually in the middle of the Booty's void, until we had adequate technology, we would not have been able to see any other galaxies near us, or wouldn't even have known of their existence until we developed telescopes capable of seeing out that far, which was sometime in like 1964 when we first started getting telescopes that could see that far out. You see, so the Booty's void is a very fascinating area, but again, because the universe started not in a homogeneous way, but it exploded in a manner that had clumping going on. That's what caused this. That's what caused us to have this exact the exact nature of what we see with these clumps. Certainly had plenty of clumping going on, for sure. So the Booty's void is a very fascinating place to me. I don't know what to tell you other than I think that it's pretty cool. I'm actually going to go to another object right now, and we'll see if we can get to it without the need for moving of the dome. And we may make it. We may not. Have to check it out.
Sorry, our new friend Alan B. Smith just messaged me, and I invited him to the stream, but he's just getting ready for bed. He has work in the morning, so
Yeah, okay.
for anyone that missed it, it is going to air Thursday at 1 a.m. Eastern on KGRA Radio. It's KGRA Radio.
Right.
I always slur that together.
Yeah.
Like I said, it's late.
KGRAradio.com.
It was live tonight, but it's actually new to KGRA on Thursday at 1 a.m. Eastern. So
Right.
it was a really, really good show. Mark kind of spoke more on the paranormal side rather than the scientific. So it was really interesting to see that side of him. I really, really enjoyed the interview.
I'm glad, and thank you. I mean, I'm glad that you enjoyed it. I thought it was kind of fun, you know.
It flew by.
It did.
It was a 2-hour show.
2 hours,
it
and
flew by.
Yeah, I don't know. I guess because I'm just talking a lot, I just kind of go off. I mean, so much to say.
I really enjoyed it.
I'm glad. There's so much to say, though, you know, and I know that I've got to actually try to kind of do a little better with that, you know. But this is a cluster of stars I want to show you guys. This is a cluster in the location known as Canis Major. It's the great big dog, which is Orion's faithful companion. And this is the cluster M41. All right, and it's also known as NGC 2287. It's 2,300 light years away, and it's a beautiful little jewel box of stars. And it was actually seen by Aristotle way back in 25 BC.
Sorry, I was just catching up on chat, and look who stopped by. Hi, Alan.
Hey, there it is. Hey,
just
Alan.
talking about him.
Yeah, we're just mentioning you, Alan. Thank you for that. And Alan's Paranormal Now.
Paranormal Now, Alan B. Smith.
Yep.
And like I said, look for him on KGRA Radio.
That's
He's
right.
newest host to the station.
Yeah, I know you're tired, Alan. You're going to bed. You got work tomorrow. So do I. But you know what? Astronomers, we never sleep anyway. So we always have these bags under our eyes. Yeah, okay, you know, that kind of thing in the morning. But luckily, I work for myself, so I only see me. But
and I was saying those nice things before I saw you in the room.
And that's the truth. She was.
That is the truth.
Yeah.
And I mean, not knocking any other hosts or anything, but I don't know. That's why I asked him on one of the breaks. I said, "How long have you known Mark?" He said, "No, Bill just introduced you not too long ago when he came on board KGRA." And
right.
I mean, I figured it was Bill that introduced you. Everyone loves Bill, but yeah, something about the interview. It was a really, really enjoyable interview. And a few people dropped by, and I know really KGRA is always the place to be. So
yeah, it really is. It really is, and there's a lot of friendly people there, a lot of nice people. I really enjoy the camaraderie. Yeah, I really do enjoy the camaraderie.
Well, thank you again for having Mark on. Good night. Thank you for dropping by.
And thank you very much, Alan. I know that we had a good time. You know, I had a good time. It was wonderful, and I love supporting you and your show because I really want to see you succeed. And if I can help do that in some small, meaningful way, then I'm very happy to have helped. You know, I think it's great. Absolutely great. Okay, this was M41, by the way, and now we're going to go to another cluster, which is way far to the north. So we're zipping up, and you can see the stars zipping by. Now as we go up to the north, and we pass by some bright stars, and finally come to rest right here. And this is, I just love being inside with the heat, man. It's like 17 out, and I am just toasty in here. Okay. This is a cluster I grew up seeing all the time. I would look for it all the time. and it was really a great deal of fun. And I'll show it to you here in just a sec. I'm going to center it up. Now you see how many stars you can see there? Doesn't look very exciting, but let's just take a 20-second photo at 10,000 ISO and see what it looks. Oh, good night there, Alan. Thank you for dropping by. He's a really good guy. I'm really enjoyed doing this show. And you know what? He's smart. He's not one of these hosts where you have to kind of carry them. Some people don't know enough, and basically you got to become the conversation. Well, Alan B. Smith is not that guy. He reads. He learns. He has an education. I mean, the guy knows what he's doing, and he's an educated host, and I absolutely enjoyed that very much. Yeah. It was really, really nice to talk to someone that actually can speak to you and understand what you're saying. You don't have to tell him anything that's cryptic. He understands everything right away. He understands everything you're saying. I love it. Very, very good. So here's a little interesting cluster. This one's M35 in Gemini.
Is this an open cluster?
It is indeed. It's an open cluster of stars. And if we want to mention anything about Gemini, or rather the M35, then basically we want to talk about this cluster. And what I thought about when I was a kid was I can't wait to get outside and look at M35 tonight in Gemini, because there's something about this cluster that was really, really neat to me. And you can also see NGC 2158, which is right here. Okay, this is the M35. This cluster here is 3,000 light years away from us. All right, and then 2158 is here. Kind of a really cool thing. And in my telescope, I never saw 2158, but I always saw M35. But here, now doing it this way, we can actually see these two clusters. And I really think that's just awesome, Now, let's be clear here about 2158. As a matter of fact, let's actually go to it. All right, so I'll go back here to my remote world, and let's just go to it. And you'll see that the telescope's not going to move very far. It's just going to literally move just a tiny bit. Okay, and there it goes. And then it's just going to stop, because that's where 2158 is. All right, and then when we actually take the photo of 2158, and we do it again, let's do it at 16,000 ISO, and do it now for the same 20 seconds. We'll check it out, how it looks. It's going to look a little interesting. I mean, you're going to see a little bit more detail of the same thing we are just looking at. And it's actually very cool. And we're just, we're kind of westward of M35 right now. All right, so here we come, and we can see now a little better what this looks like. All right, and let's just get a close-up view of it.